Hi class. In this lecture we want to talk about polynomial and rational functions. And the first topic we're going to talk about is quadratic functions. Now in this section we study polynomial functions of degree 2. So we know that the degree of a polynomial is the highest exponent. So this is just going to mean that our function is going to have a squared term. And when we have this case, they're always called quadratic functions. So all a quadratic function is, it's a polynomial function of degree 2. So a quadratic function is a function of this form. F of x is equal to ax squared plus bx plus c. And this is where that coefficient a cannot equal 0. All right, b and c can equal 0. That's not a problem, but a can't. All right, because if a does equal 0, then you just have this bx plus c, and you have a linear function. All right, so what we want to do in this lecture is we want to talk about graphing quadratic functions using what's called the standard form. Okay, so if we take a is equal to 1, all right, this coefficient here is equal to 1, and we set b and c equal to 0, okay, in this, you're going to get the quadratic function f of x is just equal to x squared, because the b and c will go away, all right. This graph is just a parabola, okay, so that's a U-shaped graph. So in fact, actually the graph of any quadratic function, no matter what the values of a, b, and c are, as long as a is not equal to 0, this graph is also going to be a parabola. So we have this standard form of a quadratic function. In this standard form here, what it basically does is it helps us sketch the graph of the quadratic function very easily. So this quadratic function, ax squared plus bx plus c, can be expressed in standard form, and this is what standard form of a quadratic function looks like. It's f of x is equal to a, and then in parentheses, x minus h squared plus k. Okay, you get this by completing the square, right? And I'm going to show you how to do that in an example. The great thing about this here, this quadratic function in standard form, is the graph of this function f is a parabola with vertex. So the vertex is the turning point of a graph. So if you look on these two graphs here, notice how this graph goes from downward to upward at that turning point, and here it goes from upward to downward here, okay? So the vertex will always be hk. Notice how they have a minus h in here, but over here we have h. That's important, okay? If this was x plus h inside here, over here you would have minus h, okay? So we also going to know that the parabola is going to open upward, so the upward shaped u here, or it's going to give it as a smiley face if a is greater than 0, so if this coefficient is positive. If this coefficient is negative, however, a, then it's going to be a frown. It's going to open downward. All right, let's do one example here, and we're going to do a lot of different parts to it. So I have this function f of x is equal to 2x squared minus 12x plus 13. What I want to do is I want to express f in standard form. So I want to take this function here, and I want to put it in this standard form right here. All right. Then I want to find the vertex and x and y intercepts, and then I want to sketch the graph of it, and then I want to talk about the domain and range. So a full, complete example here. Okay, so let's start by taking this and putting it in standard form. Since the coefficient of x squared is not 1, we must factor this coefficient from the terms involving x, so this 2x squared minus 12x, before we complete the square. So I'm going to do that. I'm going to factor out a 2, and I'm left with x squared minus 6x. So now what you're going to do is you're going to complete the square on what's inside here, okay? What's inside here. So the way you do that is you take the minus 6, you divide it by 2, and then you square it. So minus 6 divided by 2 is minus 3. Squared gets you plus 9 here. Boom. Okay, so what I've just done is I've added 9 inside the parentheses. So whatever I add inside, I have to subtract on the outside to maintain equality. Well, I didn't add just 9. I added 9 times 2 of it. So I have to subtract 2 times 9. Well, what's great about completing the square is this right here, x squared minus 6x plus 9 factors into x minus 3 squared. Okay, so I have 2 times x minus 3 squared. This is 13 minus 18 gets me minus 5. Okay, so the standard form, look, is right here. So I have my h and my k right here, and in my a. So that's perfect, perfect. It's going to help me sketch the graph. Okay, so from the standard form, we can see that the vertex is 3 comma negative 5. So it's minus h, so h is 3. plus k. Well, in this case, my k is minus 5. So that's my vertex. The y-intercept, so where it crosses the y-axis, you just plug in 0 into this equation. And if you do, zeros cancel everything with an x out. And you're left with 13. So that's the y-intercept. So to find the x-intercepts, we set these equal to 0 and solve the resulting equation, okay? Because you're going to look where it crosses the y-axis, or excuse me, the x-axis, my apologies. In this case, we're going to solve the equation by using the quadratic formula. So this is my a, my b, my c. So plugging this into the quadratic formula, you end up just getting the following, okay? So when you plug this into your calculator, the x-intercepts end up being roughly 1.42 and 4.58 respectively, okay? So now we're ready to graph this, okay? The standard form tells us that we get the graph of f by taking the parabola, okay, this original one, y is equal to f squared, shifting it to the right 3 units, okay, that's from here. Let me go back. Inside the standard form, I'm shifting it to the right 3 units. This is going to tell me to stretch it by a factor of 2 and then shift it down 5 units. Okay, stretch it vertically by a factor of 2 and moving it down 5 units. And you can see this is what I do. Plot the vertex, x-intercept, and then the y-intercept, and you get this nice smooth curve right through. Okay, and that's what this graph looks like. All right, we see that the domain is a set of allowable inputs. Well, you know, what allowable inputs can you plug into our function here? Well, it's all real numbers. You can plug anything into this. You can plug in negative the square root of 7. You can plug in 3/5, things like that. Okay, so the domain is all real numbers. And we see from the graph the range. The lowest possible value is negative 5. And then it goes all the way up to positive infinity. Okay, so that's the range. All right, class, I hope that was a helpful initial introduction.